Hello everyone, this is Mr. Navarette, and we will be going over periodicity homework number 1. Mr. Morgan tagged me in today for this one, so let's get started. Question 1 asks, how is a modern periodic table structured, and on what do we base an element's position on the table? Well, if we look back at our notes, the periodic table that we all know and love today is structured using in the atomic number. However, if you look at the shape of the periodic table, it's not just like a giant block. It has like rows and columns. And that placement is dependent on the element's electron configuration. We're going to talk about what electron configuration is later, so don't forget about it. Now, we're going to move on to number 2. Number 2 asks, where are metals and nonmetals located on the periodic table? And if you remember, we actually talked about this a long time ago. But in case you forgot, I'm going to pull up my periodic table. And here, if you look, it's no colors, but easy, quick to kind of remember it is all of the elements to the left. These are all of the metals. You can kind of use this little division as a separation. And if those are metals, that means that every element on this side to the right are the non-metals. Awesome. Let's move on to number 3. Well, question 3 asks, what's the difference between a period and a group? Well, the simple answer is what we call our rows in the periodic table. Those are our periods. Now, if rows are periods, what do we call columns? Well, columns are our groups. Question 4 asks, how many groups are there? How many periods? Well, if we look at our periodic table, we have a total of, let me count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. We have 18 columns, so that means we have 18 groups. What about periods? Well, let's count them. If periods are our rows, 1, 2, 3, 4, 5, 6, 7. Now, these elements on the bottom, those are meant to go here. So we don't add them. They're not an extra row. They're just kind of put off to the side. So we have 7 rows. So that means 7 periods. Now, we're going to move on to question 5. Question 5 asks, what are the general characteristics of a metal? Well, there's a lot of characteristics, so I'm just going to mention some of the big ones. Most of the metals that we interact with on a daily basis, we know them as shiny. We know them to be malleable. And malleable just means that you can hit it and it'll bend or stretch. You can stretch them out really, really thin enough to make wires. They're also really good at conducting heat, so great conductors of heat. If you notice, most of our pots and pans are made out of metals, so that's why. And lastly, they are great conductors of electricity. That means that through these cables or through metals, electricity can pass by really, really well. And most of our cables are made out of metals. If these are the characteristics of metals, What about nonmetals? Well, the characteristics of nonmetals are kind of quite the opposite of metals. Nonmetals they're kind of dull, meaning they're not shiny. They're really brittle, so they break really, really easily. They don't conduct heat. Because they don't transfer heat very well. And you might have guessed it, they also don't conduct electricity well. Now there's one more group, and they're the semimetals. What are the characteristics of semimetals? Well, they're somewhere in the middle. While semimetals, they are shiny, they're also brittle. So they can break easily. And while they do conduct heat, it's not as good as metals. And lastly, while they are able to conduct electricity, again, they're not as good as metals. Moving on to the next question. Number 8 asks, what is a transuranium element and where are they on the periodic table? Well, fun fact, element number 92, uranium, is the last element found in nature, so found naturally. So transuranium elements are all of the man-made elements. So all of these are just kind of made in a lab and they don't happen naturally. Where do we put them in the periodic table, or where can you find them? They are all after element 92. And because they aren't found in nature and they are kind of made in the lab, they're also all very radioactive. Lastly, we're going to move on to question 9. It says to draw a simple periodic table, label the periods and the groups. So I'm going to give it my best shot. I'm going to draw mine, and it's not going to be perfect, but make sure that yours looks better than mine. So here's my outline. I'm just going to make sure to label that all of my horizontal, so these are going to be my periods, and all of my columns are going to be my groups. And you can fill in all of the other ones. All right, let's move on to the next page. So number 10 asks, what are the common names for the following groups? Well, each group kind of has like their own special name. Group 1 is known as the alkali metals. Group 2 is known as the alkaline earth metals. Group 3 to 12, those are all of our favorite, the transition metals. Group 17 is known as the halogen. And lastly, group 18 is known as the noble gases. Why do these groups have special names? Well, this takes us to our next question. What is true about all of the elements in a given group of the periodic table? Well, all of the elements in a specific group in the same column, they have the same general appearance. So they all look similar. They might not look exactly the same, but they do look similar. They also have some of the same chemical properties. And very similar and same characteristics. These last two just mean that when placed in the same reaction, they're both going to react either the same or very close to it. Let's take a look at our first group. Well, what are some of the general characteristics about elements in group 1? Well, for starters, all of our alkali metals, they're all really shiny. And they're really soft, meaning that it doesn't take a lot of force to kind of bend them. And in terms of color, they're very silver-like. Silver color. However, one of the things that they all do share is that they are super reactive. It doesn't take much to start a chemical reaction with our alkali metals. This is group 1. Well, what about group 2? Well, for group 2, very similar. They're also soft and shiny. However, while they are reactive, they're not as reactive as group 1. And when we think about their color, they're more of a silver white color. Now, these are all characteristics that they all kind of share. Now, these are all general characteristics that they all have. Some might be a different color, but in general, this is what all of these elements share. Moving on to our next question. What about the transition metals? What do they all share? Well, this is like the biggest group, and they're all kind of all over the place. They're all really colorful. And each one has different properties. Each group has different properties. Some groups might be better at conducting heat. Some might be better at conducting electricity. But in general, all of them are able to do that exact same thing. What's really cool about these metals is that these include some of the more well-known metals. Metals like gold, silver, and copper, all really popular in jewelry. And it just so happens that they're all in the same group, right? With group 17, this is the most interesting group out of all of them. Why? Well, because they're all different colors. Bromine is a dark red, and chlorine is like a mustard yellow. So they all have different states of matter. Some are liquids, some are solids, and some are even gases. And makes you think, if they're all different, why are they in the same group? What do they all share that's the same? We're going to move on to our last one, Group 18. And in my opinion, Group 18 is the most boring group out of all of them. They are clear, they are colorless, they're odorless, and they're all gases. And it makes you think, if we can't see them and if we can't smell them, how do we tell them apart? What makes them different from one another? Now, for our last question, it says, draw a simple periodic table and label the lanthanides and actinides. So again, I'm just going to draw my outline. Now, the kind of only difference that I'm going to make is that I'm just going to add a little sliver here. And I'm going to draw my lanthanides. So this is my periodic table. Going to make sure to label that this is the lanthanides, and this is my actinides. And you may ask, why do we cut them off and place them under the periodic table? And the answer is actually really simple. If we kept them right where they were and you print it out, it wouldn't fit in your chemistry folder. So, well, that's it. Thanks for stopping by. I hope this was really helpful, and I'll catch you on the next one. Stay safe.